Welcome to Rges, Algebra 2. This is Lesson 26B, and we will be covering 8.4. Now, 8.4 has to do with reducing radicals. Now, this symbol is called the radical sign. The entire value when you're finished is called the radical. The root of a number is called the radical. What's under the radical sign is called the radicand. I'm sorry, I thought radicand, A-N-D. Radical is the answer. This is called the index. Or if it's left blank, it's 2. It's implied that it's 2, the square root. Your answer will be positive. We call that the principal square root. Okay. Unless, if it's a square root. Okay. If it's unless it's indicated before the radical sign that you want it negative. Okay. So now, to simplify, we're going to have two rules. We're going to remove the radical from the denominator. I'm going to look here for 1 second. Yeah, before we get to that, sorry. In this first examples, what we're going to do is we're going to, if you have a large number under the radical sign, you are going to convert it to primes, the product of primes. So we'll talk about that first. Convert to the product of primes. I've introduced this to you once here this year, product of primes. And then let's say my index is 2. For every 2 primes that are under the radical, pull out 1. If my index is 3, for every 3 under the radical, I'll pull out 1. Okay, etc. So let me give you an example of that. Okay, so looking at the first kind of problem, what if we had something like this? We would want to change this large number to primes, which I would be inclined to do as a tree. The other way you could do it is just either way, I'll show you. You already know, you've seen the tree method several times. So another way I tend to do it is just like this. I say, this is more conducive on paper. I say, okay, well, you know it's going to be a negative when you pull it out. Okay. So we'll just deal with that right away. And now I'm thinking 384, and I'm going to say that's 2 times what? And I'll just do it mentally, if I can here. 192, and that goes in 2 times. 192 would be 96, and that would go in 2 times, and that would be 48, and that would go in 2 times, and that would be 24, and that would go in 2 times, and that would be 12, and that would go in 2 times, that would be 6, and that would go in 2 times 3. So the point is, we can sometimes just do that mentally. I'm a little slower than I used to be, but that's all right. If you don't find that easy, just go ahead and make yourself a tree thinking of any 2 numbers. Right? Let's say 4 and a 36 would be 9, and 24 would be 16, and go from there. Right? Just keep going till everything's a prime. Okay. I think I did that right. Maybe not. Okay. 38. This 36, 24, no, 6. There we go. Okay. Anyway, not 16, 6. But anyway, so you can do that tree there. Okay. So it goes in. Oh, that's bothering me. Let me do that again. 9 times is 36. There we go. And 24 would be. There we go. That's what I wanted to do. And keep going. Now, once you've got it into primes, you put those primes in under the radical. Because your index is 3, you're going to break it into groups of 3. I have, there's a group of 3 2s. There's another group of 3 2s, leaving the rest under the radical because they don't. So that means really what I'm saying too, I would not tend to write all this, but that means 2 times 2 times 2, pulling both those forward. That's really how I want to be thinking. And then the cubed root of multiplying that back, 6. So that would equal negative 8, the cubed root of 6. And this is the answer we're looking for. This is the simplified version of the original problem. See how that works? So you're doing it by setting it into primes, taking out for every group at the same size as your index. Okay, now let's look at a couple more problems then. Okay, so several more are like that, where you're just practicing your prime factoring. Now, if I had 98, that would be, I'll just write the number part down here. That would be 2 times 49, which would be 7 times 7. I'm going to, because it's a square root, I'm going to take out the 7 and have a square root under, so this will be 7. Under the square root is still the 2. When I look at my a's, I'm looking for every pair because my index is 2. So I'm going to take one a out. So it'd be like I'm saying a to the third power, divide by 2, gives me 1 remainder 1. So this goes forward and this stays under. Okay, so my a goes forward and my a stays under because this is the exponent of the a. Then you take the exponent of the b. Again, I'm expecting you to do all of this mentally, right? And you're divided by 2 because that's my index, and it goes in 2 times evenly, so that's b squared, and no b's under. So it'd be 7ab squared 2a, and then I still have the c, just like that. Now let me show you maybe another way to look at it when I get to the variables. You understand the number part. When I get to the variable, I'm thinking like this. There's 3 a's, 2 go forward, 1 stays under. Okay, so and when I say 2 goes forward, I mean every group. For every grouping you have, the size of the index, you take 1 forward. Okay, if I have 4 b's, 1, 2, 3, 4, I'm looking for groups of 2. I have 2 groups of 2. So that would be b squared forward and no b's under. I have 1 c, no forward, 1 under, just like that. Let me show you that part of it again. This is based on the Pythagorean Theorem with always for a right triangle. And you've used this before, and a squared plus b squared equals c squared, c being the hypotenuse. So here, if I want to find the c, or the hypotenuse, it's going to be the square root of that. So this is number 1 through 4 in 8.4c. And if I know that a equals 2 and b equals 2, then I'm simply going to go c equals the square root of 2 squared 4 plus 2 squared 4, the square root of 8. Now don't leave it that way. This is why you're having this exercise here, and you've already done many problems like that, because I must simplify. Well, recall that 8 is 2 to the third power, divide by, or looking for groups of 2, I'm going to get 2 times the square root of 2. 1 out, 1 under, right? Because what I have here is 2 times 2 times 2. If I'm looking for the square root, every pair takes 1 forward, and this one stays under. And so that's how you'll do those. Manipulating formulas. Recall, if you manipulate, let's do it here. S equals, I'll get the first one started for you, making sure you understand. 1/2 AT squared. If I know the value of A, and I know the value of S, I need to solve for T. So I'm going to solve for T by taking T to that side. I'll take it in more steps than maybe you need to. And taking the S to that side by dividing, so it'll look like T squared equals A over 2S. Just flipping those around a little bit. And then what? Taking the square root. To go from T squared to T, you take the square root. To S. Something like that. And then you'll simplify. You'll fill in your values and simplify. All right. So I think you'll be able to do the rest on your own. That takes you through 8.4.